Muy bien.
Bons dias, buenos dias, good morning. Welcome to the third webinar of the series of Aqua Invert project. I'm not going to speak more about the Aqua Invert project. I think we have just spoke about that on the other two sessions. So there is not much. The other two sessions, if someone wants to look for them, they are on the YouTube and in our webpage. So just go to the www.aquinvert.eu and you'll get all we have done up to now. This session is about nutrition and feeding. And as usual, we have the presenters from the three main research groups of the project. The three main research group of the project are the Aqua Lab from the Institute of Oceanos of the University of Viçose. What's your Gercende, it's your group is the Aqua from the institute, from an institute from the University of Las Palmas, and the group from the Mariculture Center of Calheta, which is working inside RDT. So having this, we are going to start with the first presenter is Ricardo, who is working on sea urchins. And Ricardo, please.
Thank you. Okay, let me just share my screen. Okay, I think it's this.
Sorry,
one.
Ricardo, just I think everybody knows, but the methodology we have been using is that we go through the presentations and we'll answer the questions at the end. The questions, if you want to go and register the questions, you can use the facility of writing them on the Zoom. Okay. So that's only this. Sorry, Ricardo.
Okay, no problem.
Okay,
I'm sharing my screen. You're just seeing the presentation, right?
No.
No, not yet.
Let me just see what. Okay, I think it's this one. Is it?
Okay.
Okay. Okay. Okay. Hello everyone. I'm going to talk about a little bit about sea urchins nutrition. I'm going to talk about 3 points mostly: the digestive system, nutrition in the wild, and nutrition in aquaculture. I'm not going to go very deep, especially in nutrition in aquaculture, because it's usually a commercial product and there are several brands available. In sea urchins, we often look for a high quality gonad. So we need one large size, something that's tasteful, with some color and firmness. So in order to achieve this, we can go either way. We can try and feed them with natural products, or we can try and develop some kind of feed that presents this. So sea urchins are ditrosomes, meaning that the anal region forms first and later on the mouth. The teeth are present in the Aristotle's lantern, and there's a digestive tube that allows the nutrients to reach inside the animal. This is also responsible for gonad growth. Okay, here we have a picture of the lantern where we can find the teeth. I don't know if this let me just, I don't know if you're seeing my mouse, but you can see the teeth that are used for scraping the algae from the bottom or eating other animals from the benthic community. And okay, this probably should have been the first. Nutrition is the source of nourishment. It can be defined as any absorbed or ingested molecule required for the normal physiological of an organism survival, growth, reproduction, and maintenance. It should be structured so that daily dietary nutrients are provided, and most common in sea urchin nutrition can also be named as dietetics. This because when approaching this subject, some scientists talk about a diet, not only a nutrition. So the purpose here is to find a diet that's suitable for the stage of the animal, meaning that we'll have some diets that are for adults, some diets that are for juveniles, and even for larvae. In this case, the sea urchins are responsible for the abundance of algae in the nature, also for the control of benthic communities, because they also ingest some small invertebrates that are present in nature, and that will allow them to provide some gonad growth as well as some somatic growth. When talking about feed, we have artificial feeds and natural feeds. In terms of natural feeds, larval nutrition, we can talk about phytoplankton, where we have several microalgae that are pointed here, like for example, Isochrysis galbana, Dunaliella certiculata, others. In juvenile nutrition, we can talk about, for example, Uvel, like we were talking previously before starting this presentation, as well as other algae that can be provided. In adults and juveniles, there aren't many differences in terms of feeds. Then we have some more algae that can be presented. Artificial feeds. This is part of the search that I've done, and it's been available for several years. There are several compositions that are provided by certain brands or producers. And as far as I've seen, there were not many that are commercially available, which means that in spite of this being one industry that's growing and that's a lot of interest commercially, it's still not in a point that producers are providing huge brands. For example, I found some references to the United States, to Norway, and in Portugal. I know that Sparrows has made at least 2 feeds for sea urchins, me being that one of them was used by us in a project that we developed to assess the amount of protein available in a feed, which was most suitable. These feeds have been provided with several degrees of success, and luckily for us, the maintenance of a broodstock, we can use maize. It's something that's simple. It provides feed for the individual. It provides good gonads. And the only thing that's not really good is the color of the feed. It's the color of the gonad, sorry, because we have been keeping several sea urchins for some period of time, and so far we have been having really good success with maize. And I know this is short, and thank you.
Thank you, Ricardo, for your short presentation. We have only one question, but I think that probably I will have a couple of them too. I will do it at the end. Now we are going to the second presentation from Gercende. He's going to talk about the Haliotis tuberculata nutrition from early stages to juveniles. Please, Gercende.
Can you tell me full screen or?
It's okay.
It's okay. You see it full screen, right?
Yes.
Okay, perfect.
It's full screen. No, you have, sorry, you still have the, now it is okay.
Okay, great. So good morning, everyone. We're still morning or afternoon, maybe for someone. No, I think we're all morning. And so if you've been following us in the previous webinars that we've done in this series, we are now going towards the nutritional aspects in the different species of invertebrates that are being considered in the Aqua Invert project. And in this specific case, I will look now at the nutrition of the Haliotis tuberculata, but from the early stages, I mean post-larvae until juveniles. And then in the next one, it will be dedicated to nutrition and systems for the grow out. So in this one, it's only going to be from early stages to juveniles. So in the last webinar, we've stopped there. That means that we've looked at the aspects of settlement and metamorphosis that are extremely important for the abalone production. We've indicated that according to the different species or the different regions, different settlement inducers are being used, some biological ones and some chemical ones. Chemical ones are the gamma-aminobutyric acid, and then the biological ones that are being used are the mucus of larger animals that are colonizing the settlement plates, or crystoscoralline algae, or Urvella lens, or different types of diatoms. Okay, so this is okay. We've got our post larvae; they are settled, and now we have to feed them. Okay, so we've seen that normally these post larvae are being settled in around, in our case, it's 2,500 liter tanks. They are being settled on polycarbonate plates that are themselves being covered by the substrate that we are interested in. Normally the settlement is under natural light and temperature, and in the tanks the water is filtered at 1 micron. So once our post larvae are settled, then we have to feed them. And how do we feed them? We feed them with different types of diatoms that are then being poured over the settlement plates where the post larvae are settled. In order to produce these diatoms, there is different steps, because that means that it's a side culture that has to be performed next to the abalone production. Okay, so and there is a need to adapt the production of the microalgae to the nutritional requirement of the post larvae, because not all the diatoms are going to be suitable, and depending on the way they are being produced, also their nutritional quality will be different. So here you see that in order to have these diatoms, we have them first in the test tubes where we are keeping the different species, and then through batch culture, the amount of production is being escalonated until 5 liters, until bags. Okay, and here we can see what's going to happen on the settlement plates is that there's going to be a cover of diatoms, and here these little white marks are actually the place where the post larvae are going to be grazing on the diatom film. So what are the common ones that are normally used in abalone post larvae nutrition? Normally it's different types of amphora species and navicula, especially Navicula incerta. Okay, So as indicated before, in order to escalonate the production, it goes from the test tube, very small amount of diatoms, up to beakers, and then up to 5 liters, balloons or bottles, and then in bags where it's up to bags that are from 20 to 50 liters. Okay, so that's the typical batch culture. And for diatoms, between each one of the phases, you're going to need around 4 to 5 days to move from one volume to another. So what are the kind of benthic diatoms that we are using? Here we are using Navicula incerta, different types of amphora, cylindroteca, and amphora, or another type of amphora. Okay, so and then to 5 liter or 6 liter bottles. And then we produce them in bags. So if you realize in the previous slide, we had them in these kind of vertical bags. I don't know if you're seeing them, these vertical bags. And then we've moved to these horizontal bags. Okay, what is the reason why we changed this production of diatom? Because in the previous one we had a great growth, high number of cells per milliliters, and we were really happy. But what has to be taken into account is that in the center, the benthic diatoms, they have something that is allowing the diatoms to be motile on the substrate. Okay. And this is also allowing them to attach. What we've seen is that when we were growing the diatoms in vertical bags with aeration, this raft was basically getting weaker. And what was happening is that when the diatoms were poured over the settlement plates, basically they were not settling on the settlement plates and they were all going at the bottom of the tank. Whereas if we've changed to this horizontal production without aeration, the raft of the diatoms became stronger, and then we had a good colonization of the diatom film over the settlement plates. That's why we've changed the production method. So in order to start, we had to find out which kind of species were more suited for our diatoms. So first of all, we had to characterize different types of diatoms, benthic diatoms. So here you see, for example, on the left, it was Proskinia. The length is around 8 microns, opposite to the Navicula incerta that has a length of 18 microns. So for a post larvae, this is a huge difference in order to be able to feed on it. And the other ones that we've identified is the amphora, and in that case the length is of around 10-11 microns, and the Nitzia would be more similar to the amphora with around a length of around 18 microns, and they're all in terms of width, they are all between 2 and 3 microns. So this was important to find out if we had to feed the abalone with different types of diatoms of different measurements in order to have their mouth being adapted to the different types of diatoms, or if we had to feed them with a mixture of these different diatoms. Another thing that we had to find out is when do we have these diatoms and in which conditions they can be cultured. We've cultivated them in a natural condition. Okay, the growth medium that was used was F2, which is a typical medium for microalgae production. They were grown until 24 hours continuous light, and we've also measured the growth rate for the different species. Okay, and what also we wanted to find out was at which density do we have to inoculate our bags in order to have the quicker production, and how long it would take for the diatom to be maintained in exponential phase and then to reach the stationary phase, because like all the microalgae, The diatoms, they go through exponential phase during the first stages of the culture, and then they reach the stationary phase and before starting to decline. So here, for example, you can see the growth curves of two diatoms, Amphora and Navicula incerta, each one of them that have been started at different densities. So 5,000 cells per milliliter, 100,000 cells per milliliter, and 250,000 cells per milliliter. So here you can see, for example, that independently of for the amphora, independently of the initial inoculum density, the species will reach the stationary phase around day 3, 4, but one thing which is notable here is that during the exponential phase, of course, if you are at lower density, it's going to remain way lower during the exponential phase, whereas it's going to stabilize once it reaches the stationary phase. It doesn't make much difference in terms of cell density. It's different for Navicula incerta, which very quickly, independently of the initial, sorry. Okay, sorry. So we've got two next species. It's going to be Proscinia and Nitzia. So same thing. We can see that Proscinia is in a lower. It's not really different between 5,000 and 10,000 cells per milliliter in the culture, whereas it's being really differentiated for the 250,000 cells per milliliter. And in the case of Nitzia, we can see a difference between the difference in density of inoculation throughout the cycle. So based on this and on these different densities that have been used for the production of the diatoms, we then wanted to know at which moment, and also we can see with the different species that according to the species, one will reach the stationary phase at day 3, the other one would reach the stationary phase at day 2 after inoculation, other would reach it at day 4 or 5, so it will depend on the different species of diatoms that are being produced. And then the other question was, okay, if we have these different species of diatoms, at which moment do we have to collect nutritional content for the post-larvae? So there we collected the different species in exponential and stationary phase, and we've looked at their approximate biochemical composition in terms of lipid, proteins, and carbohydrate, and to see, and the energy also that they had, to see which one would be more suited for our post-larvae. And for most of the species that are being produced, it's that during the exponential phase, the amount of protein was higher for all the different species. The amount of lipids was in most cases higher also during the exponential phase, while the contrary was happening for the carbohydrate. So basically at the end, after these studies, what we've decided is that the ideal density in order to inoculate our diatoms was going to be 100,000 cells per milliliter at the beginning of the cycle, of the production cycle. This because it would quickly give us a certain amount of cells per milliliter in order to feed our post-larvae, and also because in terms of nutritional quality, our protein content was higher during the exponential phase than during the stationary phase. Then we've looked at the growth and survival of the different post-larvae that have been fed a mixture of these different diatom strains. And so basically the first study looked at the first month, okay, to have an idea of until what would be the shell length after 1 month of growth, meaning feeding a mixture of the 4 different strains. And we've noticed that we're reaching around 900 micron after 1 month. But then we want independently with different diatom species. So we looked at each species of diatom independently. And basically what we've seen is that until the 4th week after settlement, there is no, it doesn't make a difference if it's one of diatoms or another type of diatoms. And after the 4th weeks until week 10, then we could see that there was a significant effect of the diatoms on the post larvae. So basically, the one that provided the best growth with week 10 after settlement was amphora. And we've noticed a significant effect of quantity and quality of the diatom on the growth and survival of the Haliotis tuberculata post larvae. Then once these post larvae have been feeding on the diatoms, we're reaching the juvenile production. And in that case, what's happening is that the post larvae have sufficiently developed their radula and then able to, so that the easily on from the diatom diets in order to the macroalgae diets. And in that case, this is going to be further developed in the next webinar. But in that case, the what is important also is the nutrition, the nutritional content of the macroalgae that are going to be fed to these different juveniles. And here we've looked at different kinds of macroalgae species. And we've also looked at the different ways these macroalgae are being produced in order to have an idea of about their nutritional content. So, of course, we've noticed that for the same species of algae, if they are being produced in a non-enriched environment or in an enriched environment, the amount of protein is going to be definitely higher in the macroalgae that are produced in an enriched environment. Okay. But also what we've observed, is that, for example, between ulva and palmaria, they had similar amount of protein in non-enriched and enriched environment, but this would be completely different from the amount of protein that can be found in laminaria, for example. So there is huge difference between the macroalgae species that are going to be fed to these juveniles. And on top of that, on top of the way the macroalgae are being produced, there is also a seasonal effect that is more pronounced for some species of macroalgae and less pronounced for other. But if your macroalgae are being collected from the wild, there's going to be a seasonal effect on the nutritional quality, and this will have an effect on the growth of the juveniles. On top of the proximate biochemical composition, we've also looked at the amount of fatty acids that were present in these different macroalgae that are being fed to the juveniles. And again, we've seen differences in the amount of fatty acids in terms of the way the macroalgae are being produced, okay, and also between different species of macroalgae that have completely different fatty acid profiles. Here we can see, for example, the amount of EPA between palmaria and ulva. It's completely different. Same thing for DHA between palmaria and ulva. So there are also differences in these fatty acid profile, but this is going to be more detailed in the next webinar, where it's going to be essentially centered on the grow out and nutrition during the grow out phase of the production. For now, thank you very much, and thank you y obrigada.
Thank you, Gercende. It was a very interesting presentation, very detailed on this part of nutrition. I think that I've enjoyed. I think everybody has enjoyed it also. It was very, very interesting presentation. We'll speak about it later on then. Now we are going to our third presenters. There are two presenters, Diego and Mirko. Diego from Madeira, Mirko from Azores. I think and I don't know if are both going to speak, but I think Diego will go first, right?
Yeah.
Okay. Yeah. Thank you very much. You can see the presentation. It's fine now. Okay. Thank you. Good morning, I guess, to everyone. And this presentation will be rather short because little is known about how we can feed the limpets in captivity. And most research will be based in specimen down. A lot of research has been done. No, sorry. And the research that has been done is mostly focused in specimen on the wild. Funciona, yes. We can start with a short introduction about the mechanism of feeding of the marine gastropods. We will continue to speak about what is known about what is the feeding of the limpets in the wild, the few tests related in the limpets in captivity. I will finish with a very short test that will release it in captivity during the realization of the Aqua Invert project in Madeira. The gastropod feed using the radula. It's a tongue-like organ, equally developed in this animal group. It's composed by the odontophore, that is a structure that supports the radular teeth. A set of muscles move the odontophore out and inside of the mouth, and is used to grasp the food and located on the exterior of the animal in the substrate. A jaw is used to retain the food inside of the mouth of the animal. This structure is important to be known because this determines how the gastropod can feed. In the case of the limpets, the radula is a equally developed organ, can be larger than the animal itself. It is composed by here in yellow, you can find the odontophore. It's made of chitin, the same polymer that construct that made the cuticle of the arthropods. It also sustains a very strong teeth, which are mineralized and also can contain metals like iron. So the radula teeth are very strong and they are used to grasp the surface in which the limpets inhabit. You need to remember that the limpets are specialists. They colonize very hard surface and stressful environments, and live like living suction cups. So the movement of the limpets is limited by this adaptation, and consequently, the limpets will be fed mostly on all the materials that are available on the surface that they inhabit. So the motility of the limpets is limited, and this limitation must be considered when you like to develop a diet for this kind of animal. And the studies released and focused in the gut content of the limpets found that although the limpets are specialists, because like in a very specialized environment, the limpets will eat almost everything that they can find in each environment. These studies found that the gut content of the limpets contain diverse kinds of microalgae, cyanobacteria, fungi, lichens, macroalgae, and even small invertebrates that live in the communities of the limpets, like very small podifex, bivalves, crustaceans, and other ones. Consequently, this is very interesting because the limpet will will be fed on anything that we can place in the site. We only need to consider that the limpets can reach the food that we can provide. Also, other field studies found that the patella vulgata can graze on Scophilum of some communities and almost can disappear in the community of microalgae. And it's very interesting because open another opportunity. Maybe we can use macroalgae to feed the limpets in captivity. Maybe if not a principal food, or maybe also as a parallel or a complementary food for the limpets. regarding the experimental studies, has been realized very little work in this field. The main authors, Tai and Jaco, tested several artificial feeds composed by different combination of meals and flours, as well oils. The different combination might have various species of meals that apparently can maintain the animal alive for at least 6 months and also can increase the growth, can permit the growth of the animal around a 55 to 50% in this time. Regarding the larvae, the same methods have proposed that different species of diatoms and haptophysians like pavlova can promote the larval culture. With this knowledge, we realized very short tests in Aqua Invert project. We need to say that the test is very short, lasting less than 2 weeks. So we didn't know the influence of this diet in the long term. But we are able to see that the limpets can feed can ingest this kind of food. For example, we visited this commercial fish food. Here you can see the different color flakes in the same containers that contain the limpets. And a few days later, we observed that fishes with the same color of the flakes have been found, this kind of fish with the same color of the flakes. So we had a proof that the limpets can ingest and digest this kind of material. In the future, we need to check if this food is able to maintain the limpets alive, because it's very cheap and easy to obtain. In other tests, we tested the suggestion of the meals prepared by Tai and Hua, and we observed that the limpets are adequately able to ingest this kind of food and excrete it. Here you can white fishes with the same color of the white flour, and here we can see the fishes. We can see pieces of porphyra. There's another ingredient placed in this prepared meal. This meal contains soy meal with flour, agar, and marine starch. As well, porphyra to increase is recommended to promote the ingestion by the limpets. To promote the ingestion of the food by the limpets. Major problem with this diet is that these degrade very easily in the water. In 2 days, they lack all the consistency and degrade, and you need to recover it. More tests are required to see the long-term effect of this diet, as well as feasibility for the maintain the limpets alive. Regarding the larvae, we tested a special arrangement food for Artemia rotifers, and we found that none larvae survived. In fact, in a few days, the larvae disintegrated. So we cannot recommend this kind of arrangements for the limpets larvae. We also test some species of diatoms like Alamphora navicula, as well pavlova, the recommendation of the previous authors. And we found that in the case of Patelaspera, the diatoms didn't promote the settling and didn't promote the survival of the larvae, while pavlova also had the same effect, didn't promote neither survival or settlement, and also increased the rate of deformity found on the larvae. In the case of Pandela candei, pavlova also inhibited the settlement, so we cannot recommend the use of pavlova in the culture of limpets. In fact, it's probably that food is not required for the limpets larvae because they are less cytotrophic, and they can't develop until the last larval stage without feeding. Finally, regarding the juveniles, we observed that the limpets juvenile can feed on custodian algae, and we need to test the viability on the long term of the food source, because maybe due to the high mineral content of the custodian algae, the limpets can be maintained alive, but the growth must be slower. And also, the limpets can feed on the tombal film. As Gercende explained very well in the previous presentation, we can culture the diatoms and test its viability to feed the animals, and it looks very promising for the limpets because we found resin traits, and the juveniles also grow rather quickly in the few weeks that we maintain them. So we had a really good method to feed the limpet juveniles. Here you can see a Castejón juvenile feeding on an amphora, another one feeding on navicular. Sorry. And so, in conclusion, you can see that the limpets are opportunistic feeded. And this opportunistic method of life possibilities several opportunities to differ on different kinds of diets. That of limpets can forage on macro and microalgae. Also, that of limpets can accept artificial foods, and the juvenile limpet can be fed upon natural including algae and diet of biofilm. Thank you very much. Now is the turn of Mirko.
Hi, Diego.
Thank you, Diego. Mirko,
Thank you very
please.
much for the presentation. Let me share my presentation. Are you able to see anything? Are you able to see the presentation?
No, not yet, Mirko. You have to share it.
Again, let me check. Sorry, we have some problem here. Where is it?
I think maybe, Diego, have you stopped sharing?
Creo que sí, ¿no?
See, we are looking at each other, so
Okay.
you should have stopped.
And now? No? Oops.
No,
Condividi schermo. Vedete schermo intero. What's happening here? Sorry.
I'm going.
And now?
Yes, now
Yes.
Okay. Okay.
something is happening. Yes.
Okay. Let me check. Everything is fine?
Yes.
Yeah.
We're ready.
Is it okay now?
Yes, Mirko.
Okay.
Yep.
Okay.
Can go on.
So, of course, I'm presenting you the feeding, the potential feeding in limpets. A lot of information has been furnished by Diego. I'm glad to see that our source of information are almost the same. Of course, we are partnering this project. I just recall you the previous webinars where we were talking about fertilization.
Mirko,
See?
try not to move very much around because the sound is going to is fluctuating. Okay.
Okay. Okay.
Please stay in a fixed position.
Okay.
Okay.
Fixed. Freeze.
All right.
Okay. So we talk about the fertilization, the development, the larva development, and settlement. And during this webinar, we talk about the growth and feeding of the juveniles in limpets. As what we know about limpets is more related to the adults and the ecology of the limpets. The limpets are gastropods living on rocky shores. They are common on vertical rock face and boulders area, heavily beaten by the action of the waves. In the Azores, in the Micronesia, we have two main species, which are the Azorean limpet, Patella aspera, and the black limpet, Patella candei. Patella aspera is recognizable by the color of the food, and the patella campei, which is yellowish, and while in patella, in the black limpet, is brownish.
They're not listening to you well. See?
What is the microphone? It's here, I think. Okay, now are you
Yes,
listening?
no, okay. Yes.
Okay, shit. Normally, what we know about the ecology of these species is that in their habitat they are separated, and the patella aspera, the zoral limpet, occupy the lower part of the infralittoral zone, while the black limpets occupy the upper part of the infralittoral zone. Normally, these species, this is a normal separation. Of course, there are some area where they overlap. This separation is there is a common is generally there is a correspondence between the gut contents and the usual the habitat where they live. And as I told you before, this is these are limpet in general are considered herbivorous, eating mainly diatoms, bacteria, macroalgae like green, red, brown macroalgae. But has been demonstrated that they are omnivorous, because different taxa are also found in the gut contents of these animals, like amphipods, copepods, molluscs, bivalvia, but also spongy and fungi. Our preliminary analysis, our preliminary observations of the gut contents of these Aspera and Castejón confirm at least the presence of the atoms both in Patella aspera and Patella Castejón. What we know about the feeding during the early stages? Well, currently, the feeding preferences of the early stage are largely unknown, as you have seen from the previous presentation. But of course, in the Aqua Invert framework, we hope to fill this part of this information with experiment we are doing on settlement and feeding of these juvenile stages. But of course, we have some information, especially related with the Couraline crustus algae. Diego has presented some result from their work. There is another work published recently in 2019, which highlights the recruitment, the relation between the recruitment of Patella uliciponensis, which is a sister species of Patella aspera, and the presence of the crustus Couraline algae, which promotes also the survivorship of these early stages. What else? Well, we have to consider that during the settlements, there are, which is the process of transition between the planktonic way of life to the benthic way of life, a lot of structure and organ are differentiated, And one of most important is, of course, the radula. The radula, which is a feeding apparatus typical of the mollusk, and is a kind of flexible membrane, which is with numerous teeth. This membrane is pushed forward and backward in the mouth to collect particles. All these aspects, of course, are in common with other gastropods, mainly with other gastropods, and the information from the other gastropods can be used to get more indication about the feeding of these animals. And is not a case. I mean, is one of the things, because we are studying abalone, is that because the similarities between these two species. Of course, and we have to consider also that these differences. In these differences, this difference we can consider, of course, the shape and the organization of the radula. In this slides, you can see which are the differences between the two organs. In patella, normally the teeth are organized like a shelf, but they are much more, the space between the teeth, the rows of the teeth are bigger than in Haliotis. In Haliotis are well developed and organized like a rake, which brush the surface and is able to penetrate just softer substrate, while in patella, the structure of the teeth are organized in a way that they can penetrate hard substrates. Keep in mind all these similarities, but also differences. We selected different substrates for the settlement and the early growth of limpets. Especially we select diatoms. We have seen diatoms are benthic, pelagic and benthic diatoms. Normally are used benthic diatoms for the formation of biofilm on the plates. And of course, because the development of the radula changed during the growth of the animals, also the size probably of the diatom has to be changed during the growth. Other candidate is the Curalincutus agi, which are associated with the settlement not only with limpets, but also with abalone, urchins, and so on. Of course, it's problematic to get this algae on plate. You see here is just a plate with 2 months and just only small area are occupied by the coral. Another candidate is Urvalens. This is a macroalgae, green macroalgae, courtois, growing as a flat rosette and is perfect to be grown on plates. And the germs of Urva, because these are also species used in other culture. The system that we are thinking and we used for test different biofilms is something like this. Are tanks of 60 liters, in which we add competent larvae of 0.5 larvae per milliliters, with the temperature ranging between 17 and 18. That is more or less the temperature during of the spawning. And normally after the settlement, we increase the flux of the water just to keep clean the water. So first of all, the first trials involve the plate with Ketochorus. Ketochorus is medium-large diatoms with an apical axis of ranging between 11 and 40 micrometers. So what we have observed during the first 5 months of growth, that the daily growth rate was really low. So we thought to add other food, and so we add a plate with Urvella. The larvae were able, the post larvae were able to transfer, and they choose to transfer on the plate, and they start to eat on Urvella. And as you can see, after 6 and 7 months, the growth rate just boosted. So what we conclude, we are thinking that, of course, different species of diatoms could be a better source for the early growth, or at least the Ketochorus is just good for the first stages. But Urvella lens can be a really strong candidate as a feeding source for the early growth of these species. So in the black limpets, we use just plate with Urvella. And what we observed in the first 2 months, still the daily growth rate was really low, but something changed after in the 3rd month, and the limpets started to eat on the Urvella, probably because the radula was much more effective in scrape the substrate, and also the digestive enzyme will be able to digest these green algae. So the conclusion, what we think is that Urvella lens is not an optimal source of feeding for juveniles, at least since 2 months. But then the nutritional value of these algae seems to support really high growth rates. So to conclude, in the future, we are thinking to test different diatoms species for the early stages, determine the timing for the use of Urvella lens. We hope to get a plate with cooler courtois algae to test also these algae and the use of Urvella. And finally, we would like to compare the daily growth rate of these feeding source and the nutritional values of these sources. With this, I conclude, and we hope that in the framework of the project, we will be able to get more information about the feeding behavior and, of these species. Thank you for your attention, and feel free to make any questions. Eduardo, the word is yours.
Thank you, Mirko. You were the last presenter. Please, can you stop sharing the presentation?
Yeah.
You are still sharing.
Sorry.
So we have a few questions, and I don't know how to say it in English. In Portuguese is bate-papo on the discussion panel. Mirko, you are still sharing.
What about now?
Yes.
Jesus. No,
So the first question is from Gercende to Ricardo. It's about the feeding of Urchin and about the compound feed. Compound feed are used to feed wild captured animals or animals produced from larvae in aquaculture, Ricardo.
To answer the question, both. There are some feeds that are for a broodstock that can also be applied to a wild capture. And there are also some feeds that are for larvae. The success rate is something that's not wide. It's rather short, and it also depended on the species. For example, if I'm not mistaken, there's a larval feed in Norway for Strongyocellus droebacensis. That's around 80% of success for larvae. It could be interesting to eventually try that feed also in Paracentrotus or other species. Also, just one question is Mirko sent me a message asking if I think that green macroalgae could be used as a feeding source for sea urchins, and in this case he meant Ulvella lens. Yes, I'm pretty sure it can be used as a microalgae to feed sea urchins, regardless of the species, because one of our tanks at the center is outside, and at one point it was empty without animals, and we let it grow. It grow algae, biofilm, everything. We have not identified the species. And then we placed some limpets, some sea urchins of Paracentrotus and Spherichinus. And in 5 days, the tank was clean, totally clean. So yeah, I'm pretty sure they will eat Ulvella as everything. And all of the animals, we could see some trails of their feeding patterns. So I'm pretty sure it can be used. The effect on growth and eventually on the gonads is something that we eventually will have to access.
So you haven't tested it for adults, really? You just know that you just say that they eat everything.
No. I'm talking about adults.
Yeah, only about adults. Okay.
Yeah.
It makes some sense that they are not. If they have hungry.
Yeah. That's the fun part. They were not totally angry because they have been under feeding control. They were feeding for quite a while. We just had to move them to that tank. so that we had some space. And what we noticed is that they eventually eat everything. So it was a bit of luck and something that we still need to go a bit deeper into.
Very well. You were also saying that the compound feed for adults was fabricated also in Portugal. Who is fabricating it?
I think Sparrows has some diets, because some of the papers that I've read, they mentioned some collaborations with Sparrows. That was, yeah, that's why I said it's something that's available in the industry, but maybe not available on a market size. So probably if we get in touch with Sparrows, I'm pretty sure they'll have some diets available for sea urchins.
Okay, very well.
Yes,
Thank you.
Gercende?
Question, in the industry, I mean, most of the people that are producing sea urchins, are they producing them from larvae and feeding them from larvae up to grow out? Or most of them are being taken from the wild and then used, the feed is used for the grow out and then being sold? What is
There's a mixture of lines of work. There are some research on grow out and some research on feeding, either for in terms of feeding for, let's say, just fattening and getting them to market size. That is often they are emphasizing the final touches of the gonad, meaning they are working mostly on providing a diet that provides a good gonad that's suitable for the market, with color, firmness, and all the characteristics that the market needs. Simultaneously, there are some lines of work that are working on grow out and feedings to provide a stable and continuous lines of sea urchins to the market. I hope that answers the question.
Okay, so basically it's half. The sea urchin producer, half of them are collecting from the wild and just doing fattening, and the other ones are producing from larvae.
Yes.
Okay.
Very well. Diego, there is also a question for you from Gercende. I think you have seen it. So the question is if you can indicate the types of macroalgae that have been tested to feed patellar adults in captivity.
I didn't found this kind of study yet. I think that it has been done, this kind of study has been done very little because it will be very hard to find. To far, the studies on macroalgae and fish based on wild study. Study based on the field. Are being focused in the population of many of them of Scophilum together with limpets. Either placing the limpets in controlled condition with a Scophilum or with a Scophilum, or focusing on how the density of a Scophilum changes during the year together with the limpets. But in captivity, I didn't find this kind of study. And yes, apparently the limpets can feed on certain type of macroalgae, and some studies also indicated that the limpets can grasp fragments or pieces of macroalgae in the environment. So maybe you have a possibility with this kind of diet.
And have you tried using the sea urchin compound feed for the patella, for example?
Yes, I use it the same pellet indicate Ricardo from Aqua. What is the Sparrows? It has Sparrows, Ricardo?
Yeah, it was a diet it was feed provided by Sparrows to a trial that we did with sea urchins.
Yeah, and the limpets didn't touch the pellets. I placed pellets in the same place with the limpets. I didn't touch.
Okay, interesting.
Diego, just one question. When you placed the pellets, did you place the limpets on top of the pellets?
No, and like push next to the, yeah, it's possible that the limpets can reach the pellet because the pellet is very big, but
Yeah, that's what I was thinking.
Hmm.
Okay.
There's a possibility. I think we need to fragment the pellets and try to split it in small fragments.
Maybe if we were able to spray pellets on the surface, could be an idea to make the food available. It's something that, for instance, in sea urchins is done, to spray the feeding on a surface and then use this as a feeding source for the animals. Maybe something like this could be. I think that in the case of the limpets, feeding the adults will be really challenging.
What can you repeat, please?
It was just a consideration. I think that with the adults, feeding the adults will be really challenging. It's not so easy, but actually you demonstrate that in some way they can eat the food. So we are in the right way, I hope.
Gercende, I have one question for you. When you were speaking about the microalgae, you have explained quite well the growth of microalgae for each species, how long it would last. You have also explained quite well the difference on their on the chemical components of them along the time. So what could happen? But what are, have you tried different enrichment environments also for microalgae? And what's the implication of these different enrichment environments with their with their chemical chemical constituents and nutritional impacts for the juveniles. So what were basically the nutrients that you have been using on the environment, and have you tested them different environmental enrichments? What were the implications for?
Okay. You're talking macroalgae or micro? Okay,
Micro.
no. In all the diatoms culture that we've done, we've always done them using F2 medium. For the diatoms, we've only used F2 medium. We haven't used any other medium.
Okay.
So
Okay.
there's no other ones. I could not. I mean, at bigger scale, I think it could be interesting to test any agricultural nutrients for bigger scale. But until now, we've only used the F2 compound. F2 medium for the diatoms production.
So we need to know which is the impact of using different media to the on the nutrient.
Definitely. But I mean, you know, in any microalgae that you're going to produce, it's going to be affected by the amount of nutrients you're going to have, the amount of light, the temperature. So all these will affect your production, basically.
Okay, so basically you have fixed that. You have fixed the nutrients, that treatment, and only that treatment, and no other.
Yeah. Until now, that's what we've tried. Yeah.
Very well. So we are using a different one, as you know. So we need to understand which are also the timings and the growth of the different cultures of species. Very well. Thank you very much.
Okay.
Let me see if there is any more question. Oh, you have for everyone. Very interesting. The rather difference between patella and Haliotis. Yes, indeed, it is. And the implications of that on the feeding should be quite interesting to relate. It was a good point, Mirko. I don't know how we can do it. Is there any difference between the rattle of the two species, of the patella species we have been using?
Probably there are, but as far as I know, there are no studies on that. And even in the early development of the radula in both species, there are no information. It's something that is something interesting, and probably the structure of the radula make huge differences between the two species in Abalone and in Haliotis. But this is not the only one, because it's demonstrated that also the development of the digestive apparatus and different enzymes can have a huge influence also on the diet that they are able to process. Let's see. Yes, of course, it should be really nice to some way to try to see the relationship between the diet that we are giving them and the structure of the radula.
Very well. Any more questions about do you have, or you, or yeah? Yes, Ricardo.
No, on my part, it's all good.
So, are you going to think about what we have talked about, and then we will provoke each other again?
Yes.
Okay, very well indeed. It was interesting and very interesting webinar. I think it was provocative in some points. Diego was provocative on the diets. I think we have to think also, Mirko, about that. And thank you very much to you all for coming and for being here. It's very pleasant to see you. And now I only have to wish you a very good Christmas, right?
Likewise.
Or we will meet before Christmas.
Yes, we will. Us, we will, for sure.
We will. Well, I'm going on holidays on the first week of December, because I didn't have almost anyone with no holidays on this year. So as the university don't let us accumulate to the other year, I'm forced to go to to holidays. I'm very sad. I'm very sad, as you can see by my face.
Okay, so enjoy, have a good Christmas, Eduardo, and have a good holiday. And thank you for managing the webinar today and for getting the questions and keeping the times. Great, thank you.
Great. One thing, Gercende, have you submitted the changes?
I will talk to you about this later on.
Okay. We'll talk about that.
Okay.
I was just going to say, if even in the holidays, if you need anything, you could just please.
Okay. I'll send you a message about that.
Yes, on the iPhone, not on the. Okay. See you. See you.
Thank you, everyone, for being here. See you. Bye.
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 See you.
Bye.